Water and Polarity by Eliza Lane. It all starts when one oxygen atom meets two hydrogen atoms and they decide to form a covalent bond. See, oxygen is highly electronegative, meaning that it attracts electrons. The electrons of the hydrogen atoms are pulled towards the oxygen atom. Since electrons have a negative charge, the oxygen atom is now slightly negative, and the hydrogen is slightly positive. And boom, it's a magnet. Well, no, not exactly, but it is a polar molecule. And right here, some crazy things start to happen. When a few water molecules are put in close proximity to each other, this starts to happen. But why? Well, the negative oxygen attracts the positive hydrogen of another molecule, and vice versa. This is called hydrogen bonding, and it's the reason water is so cool. Thanks, hydrogen bonding. You've probably realized by now that water is essential to life, but it's important in a lot more ways than you might think. So let's go back to that hydrogen bonding over there. See how the water molecules stick to one another? That's called cohesion, and that becomes very important very soon. Cohesion is responsible for a lot of the cool properties of water. It's the reason water is adhesive or sticks to other substances. And adhesion is the reason for capillary action. This basically means that when you put water in a tube, it starts to climb the walls of the tube because one molecule adheres to the side and drags every other one up with it. If we were to make this tube really small and stick it in a tree, boom, tree can now get water from the ground to its leaves without ever having to move. Another property caused by hydrogen bonds is its high surface tension. This basically means that it takes a bit of effort to break the surface of water. The hydrogen bonds on the top layer of the water allow the molecules to cling to one another, forming a kind of film that can hold up very light things, such as this bug. But the hydrogen bonds can't hold up something with a lot of weight, which is why this cow sinks to the bottom of the lake. Let's take a minute to talk about animals in lakes. Water is very special because of what happens when it gets cold. See, when water freezes, it stabilizes the hydrogen bonds that hold the molecules together. The molecules end up getting pushed apart from one another, making the ice less dense than the liquid water, so ice floats. If ice sank, it wouldn't be able to act as an insulator for the liquid below it, which means that liquid would also freeze, and we would have some very frozen fish. Water also moderates the temperature of the air around it. It has a very high specific heat capacity, meaning that it takes a lot of energy to change its temperature. This, too, is due to hydrogen bonds. To alter the state of water, you have to pull apart the hydrogen bonds, which takes a lot of energy. So when an area is receiving a lot of heat, a lot of it goes into changing the temperature of the water, meaning the air around it gets less heat energy. This also works in reverse with cooling. And finally, the universal solvent. Water is often called this fancy title because of its ability to dissolve a lot of substances. Again, water's polarity comes into play here. When the molecules of the substance to be dissolved, or solute, are placed in water, water molecules immediately begin to attach themselves to the different atoms of the solute molecule based on their charge. The positive hydrogen atoms attach to any negative particles, and the negative oxygen atoms attach to any positive particles. The water then begins to tug at these particles using its polarity, and eventually will break apart the substance, dissolving it. Well, that's basically water. If you liked this video, please make sure to give it a big A+, because it took me forever to animate it, and I probably killed a lot of trees.